Welcome. I have completed the repair of the main guideways of this machine using manual scraping. It's an interesting process that allows you to restore worn working surfaces and recreate them anew, geometrically precise, flat, and straight. At first glance, it may seem strange, but this method truly allows you to achieve high surface quality. And under certain conditions, when the process is properly supported, it's possible to produce the most perfect flat surface, even better than machine precision. There was a time when I couldn't understand how it was possible to surpass machine precision by hand. And also, where did that first mega machine come from, the one that gave birth to its smaller copies, passing on its geometry? But after learning about the principles of scraping, I found answers to these somewhat sacramental questions. So, once you're well prepared and have the necessary measuring tools, you can take a scraper in hand and, little by little, create a precise flat surface for your favorite machine. But enough philosophy, let's return to today's topic. Now, after scraping, the geometry of these guideways is very close to ideal straightness. All this complex work is shown in detail in the previous episodes. I invite you to watch them. Today I will perform the final verification, precise measurements of the geometry of the V-shaped guideway. Together we will see whether the result of the scraping matches the high precision I previously claimed. For me, it's like an exam. Did I truly manage to align the guideways accurately? The geometry was checked using an autocollimator and a precision level. As an indicator for scraping, I used pigment applied from a high-precision straightedge, which I made myself using a complex method from an I-beam. There is also a separate video about this on my channel. This straightedge made from an I-beam works excellently, and today's video will confirm that. This is a fragment from the video where I made my straightedge from an I-beam for scraping this machine. Now, after finishing all scraping work, it's time for the final measurements. This will help evaluate the effectiveness of the method I used. The guideways were scraped manually, without machine power, purely with muscle force. However, the control was done at a high level, using precision optical equipment, an autocollimator. Earlier, I already performed similar measurements during scraping for ongoing control. And at the end of scraping, when the control showed me good straightness, I recorded for myself the state of the geometry. At that moment, the guideway had a smooth sag in the center, 6 microns. At that point, I considered the result sufficient and stopped scraping. After that, I scraped the table's guideways, worked on the table's oil station, the spindle lubrication station, the coolant system, and other details. Several months have passed since then. Today, the goal is to repeat these same measurements, now, before placing the table on the guideways, several months after scraping was completed. I want to carry them out as transparently and reliably as possible, with minimal measurement error. To document this control measurement, I use synchronized video recording from 2 devices, a camera and a smartphone. Previously, I mentioned that the measurement showed a smooth sag in the center of the guideway, 6 microns. I have referred to this in earlier videos more than once. Back then, measurements were made using two mirror bases, 300 mm and 1000 mm, which increased measurement reliability. However, to confirm the result with documentation, it's important to capture everything on camera. Especially now, before reassembling the base and table. It's spring now, and the room temperature is plus 15 degrees Celsius, while the previous measurements were taken in the summer at plus 27 degrees Celsius. This affects the geometry, because the cast iron base is rigidly anchored to a concrete foundation. Cast iron expands less than concrete when heated. Therefore, today's result is expected to differ slightly due to seasonal temperature change. I am using an AKU 0.2 autocollimator with a precision of up to 0.2 arc-seconds. To demonstrate clearly how the crossmark shifts, I placed a sheet of paper under one of the supports of the mirror platform, with a 300 mm base. This caused a displacement of 50 arc-seconds, which corresponds to the paper thickness of 0.073 mm. Here is the step-by-step calculation with geometric explanation of the arc and angular ratios. This is how you can clearly see how the instrument reacts to microscopic displacements. If the base of the platform is 1000 mm, a displacement of only 1 micron by one of the support legs, while the other remains static, causes an angular shift of the mirror, which is already detectable by this sensitive autocollimator. This means we can observe and control micron-level deviations over a 1 meter distance. Here is the field of view inside the eyepiece of the instrument. At the bottom and right side of the screen are the fine-tuning scales, which function somewhat like a vernier scale in standard measuring tools. The scale markings are labeled in arc minutes. Each division from center equals 10 arc-seconds. I still have some autocollimators for sale, tested, calibrated, and complete with accessories. But only a few remain. Contact through email or comments.
Другий крок. Третій.
In this measurement, the mirror is mounted on a 300 mm platform.
Четвертий.
The support legs have PTFE pads and are hand-scraped to match the prismatic guideway surfaces. This ensures optimal contact for smooth progressive movement. Measurements are performed from the right oil pocket located near the edge of the guideway to the opposite pocket on the left, 8 positions total, in 300 mm steps. This is the working area of the guideways. Outside the pockets, the platform cannot pass without falling in, so the measurements are limited to the working zone,
Шостий.
even though the straightness continues beyond the pockets.
Сьомий. 300. 300.
The measurement process is recorded synchronously, the smartphone is aimed at the instrument scale, while the camera is focused on the platform.
300.
I move the platform and voice each of the 8 positions. From the video, we will be able to determine the crossmark shift in each position. Based on this data, we can evaluate the condition of the guideway. So, let's inspect this V-shaped guideway. I've placed on your screen the footage from both cameras. Here's the view through the instrument's eyepiece, and here's the external camera view.
Есть? 12. Нуль. 300. 300. 300. 300. 300. 300. 300. 300. 300.
In this way, I hope I've carried out the measurement clearly and convincingly. I tried to perform this measurement as precisely and carefully as possible. I believe the goal was achieved.
300. 0. 300. 300. 300.
You are now witnessing all the mirror displacements that occurred. During the movement process, the largest deviation is observed at position 6, 9 arc seconds.
300.
The measurement ends at position 8, with a displacement of 5 arc seconds in both planes. Here are the calculated results based on the collected data. Results for line A and line B. On line A, the maximum deviation is 11 microns. On line B, the maximum deviation is also 11 microns. If the foundation didn't influence the geometry of these guideways, would continue refining them further. But as the overall temperature rises, the current central hump of 9 microns, measured in the vertical vector, will transform into a similar sag. Therefore, I consider the results sufficient and will finish the scraping of these guideways.
Починай.
For comparison, here is a fragment from a previous measurement, taken before the repair, on the worn guideway.
Позиція 2. Позиція 3. 4. 5. 6.
It's easy to see how significant the difference is between the instrument readings before and after the repair.
8. 9. 10. Дроблю.
Analysis of the obtained data shows, at the current temperature of plus 15 degrees Celsius, the central part of the guideway is slightly raised, about 9 microns. At plus 22 degrees Celsius, the surface becomes straight. At plus 30 degrees Celsius, a sag of up to 10 microns appears. This is caused by the difference in thermal expansion coefficients between cast iron and concrete. I would also like to point out that, in my opinion, the design of the foundation for this machine, and similar ones, should be revised. This is not difficult to do, and not more expensive either, but it would eliminate the thermal deformation of the machine's frame. Thus, I've attempted to document the accuracy of the surface after the repair. Of course, this is not the limit of possible precision, it is defined by the capabilities of the measuring instruments. As long as we can observe deviations, we can correct them. Once the instruments can no longer detect changes, that is the ultimate precision limit, so, the limit of possible accuracy is the precision of our measuring equipment. The repair of the surface grinder is coming to an end. Soon, I'll be able to move on to other interesting topics. I invite you to subscribe to my channel. I hope the upcoming content will be just as engaging. New opportunities are opening up. Please leave your comments, questions, and thoughts. Thank you for watching, for your support on Patreon, and for your sponsorship. See you again soon.